Hey there guys, today we are going to have more fun with these composite shapes, with these composite figures. Let's get started where we left off yesterday in the notes. We're going to be looking at example 3. Now you do not need to turn this in today, just so you know you had to turn in those notes for yesterday, but these notes you don't have to turn in. You will just be turning in your worksheet, which we'll look at in just a second. So reading example 3, it says, Janice needs to replace the flooring in her living room and hallway with carpet squares. A floor plan is shown. So part A asks us, what is the total area of floor that needs to be carpeted? All right, so you've got this kind of big living room here and a hallway out to the side. And in terms of math, you could call this a composite shape. You have several different shapes kind of smushed together to form this irregular shape here. So how can we divide this up and compute the area? Well, let's try to do it the simplest way for sure. And I'm just going to kind of cut off the hallway so you have this rectangle here. And then what I'm seeing here for the living room is you have a big rectangle and a semicircle attached to it. So let's just divide the rectangle from the semicircle. So basically you're going to find the area of the little rectangle, you're going to add it to the area of the big rectangle, and you're going to add that to the area of that semicircle. Okay, so let's get started with our little rectangle. It looks like the little rectangle is 3 feet by 12 feet. And as you know, the area of a rectangle is length times width, or you could say base times height. Either way, 3 times 12 is going to give us 36. So I'm going to say 36 feet squared by this guy. Okay, now what about the big rectangle? That's this one right here, right? Okay, so it's 18 feet on the bottom. And what about this side? Well, they didn't write it over here either, so we need to do a little math on that. We've got 5 feet for this chunk, we've got 3 feet for this chunk, and we've got 6 feet for this chunk. So 5 plus 3 is 8 plus 6 equals 14. I'm going to write it over here. So 14 feet. Let me make sure I did that right. 11, 14, yes. Okay, good. So now let's figure out the area of it. We're going to go 18 times 14, and totally fine to use those calculators. Okay, 18 times 14 is 252 feet squared. And I'm just going to write that right here. If you want to keep track of yours differently, totally fine. This just seemed convenient to me. Okay, now what about that semicircle? The key to finding area of a circle and then the semicircle is to figure out the length of the radius, right? That's from the center to the side. So let's see if we can figure this out. So we know this total length here is 18 feet. We don't know the length of this line, but we can figure it out by doing 18, which is the total, minus 8. So we know that this whole thing, which is actually the diameter of the circle, is 10 feet. Now, do we use the diameter of a circle in our area formula? No, we use the radius of a circle in our area formula, which is going to be half of the diameter. So half of the diameter, half of 10 feet, is going to give us 5 feet for the radius. And now we can figure out the area of our circle. Let's go ahead and write down our formula this time. We're going to do pi r squared. So pi is pi, that's a number. You can use 3.14 if your calculator doesn't have a pi button. Mine does, so I'm just going to use the pi button right there. It's kind of glary. Can you see? It says pi right there. Okay, so pi r squared. So we know that's pi. What was r again? Oh, it looks like it was 5. Okay, so 5 squared, let me just write that down. So we have pi times 5 squared. Now make sure you square that 5 before you multiply by the pi, okay? So you're going to get pi times, let's see, 5 squared is 25. You can always use your calculator for that if you want. Make sure you're doing 5 times 5, not 5 times 2. You want to multiply 5 times itself, or you could use the little button on your calculator that squares things. Mine looks like this. Yours might look different. Okay, so pi times 25. Now we definitely need our calculator for this. So you can do pi times 25, or you can do 3.14 times 25. I'm going to do pi times 25. And that gives me, well, it gives me 25 pi. That's not what I'm looking for. I want a decimal approximation. So I need to push my decimal button. And it's going to give me 78.53. Now let's see what would have happened if I had done 3.14 times 25. So that's just going to get me 78.5, which is the same enough for our purposes, and that's actually what I'm going to use right here, 78.5. And that's going to be feet squared. Okay, now all we have to do is add them up. So let's do it. We have 36 feet squared plus 252 feet squared plus 78.5 feet squared equals 366.5 feet squared. All right, excellent. We're going to go on to part B. Actually, wait a second. We're not ready to go on. You know what? I just stopped the film so I could get a sip of my tea before it got cold. And I realized I just made a big mistake. Have you caught the mistake? Think about it. I just made a big mistake in one of these three shapes. I'm going to let you think. Maybe you've already caught it. I'll give you a hint. It was in this one right here. What did I forget to do? If you already know, awesome. If you don't know, feel free to pause. Okay, and now the big reveal. What did we do wrong? Well, I found the area of the circle, but it's not a circle, it's a half of a circle, so I better cut that in half, right? Okay, so let's do that. I'm just going to take my 78.5 and divide it in 2. 78.5 divided by 2, and that's going to give us 39.25 square feet. All right, now let's add everything up. I'm going to go ahead and X that out. So starting back here, we've got 36 plus 252 plus 39.25 equals 327.25 square feet. And for square feet, you can just write it just like that. Okie dokie, so this is my answer. I'm going to put it in a circle. And let's go on to part B. All right, so in part B it says each box of carpet squares contains 9.65 square feet of carpet. You guys know where we're going with this already, don't you? How many boxes should she buy? Okay, these squares are sold in full boxes only. That's realistic. I'm putting tile in my bathroom right now. You got to buy the whole box, even if you only need one tile out of it. So if she has a total of this many square feet, how many of these boxes does she need if each box contains 9.65 square feet? Looks like we need to do some dividing, right? Let's do this number, the total square footage, divided by the number of square feet included in each box. And it should give us the number of boxes needed. So I already have that number there, and I'm going to divide it by 9.65. And we're going to get 33.9 boxes. Okay, so can she go to the store and say, yeah, can I get 33.9 boxes of carpet? They're going to be like, no, you can get 33 boxes of carpet, or you can get 34 boxes of carpet. Which one should she get? And don't just think rounding here, although in this case it does work. If she got 33 boxes of carpet, there'd be a little corner in here somewhere that was just bare floor. Do you think that would make her happy? Probably not. She probably wants the whole floor covered. So it sounds to me like she needs to get 40 boxes, so, not 40 boxes, 34 boxes, so that every little bit is covered, and maybe she has a little extra, that's fine. So we're just going to round that up to 40 boxes. And I just want to say again, I know 9 rounds up to, dang it, I said 30. Oh, trying that again. 34 boxes. Yes, 33.9 rounds is up to 34, not to 40. Okay. But I do want to make this point. Even if the math had come out to be, say, 33.1, that would round down to 33, right? Now, yeah, in terms of math it rounds down, but in terms of her needing enough carpet, you would still want to make that into a 34 because you don't want 0.1 bit of your square footage in your living room to be bare. You would want to go ahead and round it up to 34 boxes. Okay? So here it's clear that we should round it up, but with a smaller decimal, I know it's going to be kind of like, what should we do? Always bump it up to the next one. Okay, on to part C. Great, sorry to keep pausing on you guys. This tea is just so good, but I'm done now, so I'm going to put it down. Okay, so for part C, it says one box costs $32.95. How much will the flooring cost? Okay, let's read it again. One box costs this much. And how many boxes do we need? 34. So let's do 34 times the cost of each box, $32.95. Okay, so 34 times 32.95, $1,120. $1,120.30. Or you could write it this way with a nice dollar sign. Okay, $1,120.30. Alrighty, we got that. Now, if she gets a coupon, this is part D. If she gets a coupon for 20% off, how much would the flooring cost? This is kind of like our warm-up that we did yesterday, right? You get a coupon for 20% off. So that means you're taking 20% off the whole price, which was 100%. The whole anything is 100%, right? If you take 20% away from 100%, you're going to be left with 80%. So the simplest way to write this would be 80% of the full price. So 80% of $1,120.30. Now, how do you take 80% of something? Well, first you convert to a decimal. So move the decimal 2 places and you're going to be left with 0.80. Or you could just say 0.8. They're both the same. So 0.80, and then you have to multiply it times this number. 1,120. And I know it's easy to think, well, we're going to multiply it, and now that number is going to get bigger, and she's going to pay more, right? Because multiplying makes things bigger. Well, multiplying doesn't always make things bigger. When you have a number less than 1, multiplying is actually going to make things smaller. So let's watch that happen, and we're going to save, what's her name? We're going to save Janice some money. Okay, so 0.8 times the price. 0.8 times 1,120.30 gives us $896.24. $896.24. All right, there's her new price. Now, is there another way you could have done this? Absolutely. You could have done 20% of the price and then subtracted that from the price. Totally can do that. This way is just a little bit faster, so that's why I showed you that way. Okay, one final question. What if the tax was 6.85%? Okay, well, you're going to take tax on the new amount. In other words, you would do the tax on the actual amount she paid. Did she actually pay this? No, she actually paid this. So we're going to take that number and multiply it times 0.685. Yeah, let's do it that way. And then we can add it together. Or we can do the shortcut way. Let's do it the easy way. The easy to explain way, right? We're going to take 6.85% of that, so 0.0685, and we're going to multiply it together. So lots to type in. You've got 896.24. Oh, I've already got that. Okay, times 0.0685, and I'm going to get $61.39. So this is the amount of the tax by itself. That's just pure tax. You still have to add it back to the amount she paid. So let's add that, 61.39 plus 896.24, and you get 957.63. So I'm going to write that here, 957.63 for that final price. Now, the other way that you could have done this is, let's see, so she's already paying this price. This is now the whole price that's being taxed, right? So forgetting about this part of the problem, at this point, this is 100% of the price because we've already taken the discount. She paid it. How much did she pay? $896.24. That's 100% now. Now, you're going to add that 100% to this 6.85%. So in other words, 100% plus 6.85% equals 106.85%. So what you could have done is just multiplied this price by this percentage. I'll write it down for you. So 896 times 1.0685. So if you want to find the tax, the total including tax, in a single step, this is how you would do it. So basically you're putting a 1 in front of the tax to represent the amount she has paid. And then you multiply and you're going to get the same number. So let's do that real quick. And then we'll start looking at the assignment. 896 times 1.0685. 957. Oh, that's weird that it's different there. I must have had something approximate in there. Either that or I mistyped something here. Yep, you know what? I forgot to put the 24 cents in there. If I'd put the 24 cents in there, then it would have been exactly the same. Okay, so just 2 different ways to do the same thing. And don't forget your pennies like Miss Smith did. Let's take a look at that assignment. Okay, so I realize you guys have already watched about 15 minutes of video at this point. I want you to spend less than 30 minutes on this assignment, okay? So if you get going on it and it's taking you forever, then maybe you just focus on the first page, okay? Or maybe you try to get through number 9. Number 9 is kind of a more complex problem. But whatever you do, you don't have to spend all day on this. All right, so looking at number 1, you're going to break it down. How do you see it? You should do it however you see it. I'm going to talk through ways I see it. I see a square in the middle. And then I see 4 semicircles. And now the semicircles, make sure there's 7 all the way across. So for the radius, you're going to need to use 3.5, right? Right, okay. So you could do pi r squared with the 3.5, and then you could divide it in half because it's a semicircle, and then you could multiply it by 4. Or you could think about it like, boom, boom, those 2 semicircles make a whole circle, and boom, boom, those 2 semicircles make another whole circle. So you could think about it as a square plus 2 whole circles, if you want to. Do it whichever way you see it. The way you see it is better than the way I see it because it's your way. You know what I mean? Definitely go with your own way. What about over here? Different ways to do it. I would definitely cut off a semicircle here. Use that for your radius. You might think of this as a trapezoid, or maybe you could figure out a way to make this a rectangle plus a triangle, but I'm thinking trapezoid would probably be simpler. And how are you going to find the length of this? Well, definitely use this length. This is the radius here. So if this is 5 millimeters, then you know that this part is also 5 millimeters. So that should help you find what this side is also, right? It'd be another 5 millimeters. Okay, cool. Here you could do the rectangle plus the triangles, or you could do a big rectangle and subtract out a trapezoid. Whichever way you want to do it is the way you should do it. Now you get to the next page. Let's look at number 9 really quick. More complex problem. You have the front of a garage, except for a door, needs to be painted. And the door is 1.5 meters high and 2 meters wide. First thing I would do is label my drawing. 1.5 high and 2.5 wide. So how many square meters will be painted? So you've got this complex shape here. You need to divide it up maybe into a rectangle and a triangle, or if you want to do something fancy coming down this way with a couple trapezoids, you go for it. That'd be great. And then once you're done, make sure you subtract out the area of the door because the door is not getting painted. And then it's kind of like the one we did in the notes. You have to figure out how many cans of paint you're going to need. And it's only sold in full cans, so make sure you round it up if you get any kind of decimal. And then you're going to figure out the cost. You do not have to figure out any 20% off or any tax rate, so not quite as expensive as what we just did in the notes. All right, I think that's enough for now. I'm going to stop talking. Thank you for watching. Let me know if you have any questions, and have a great day. Bye.